நாளைக்கு காலையிலயா? எவ்வளோ இருக்கு? க்ளீன் ஆயிடுச்சா? Good evening, everyone. Are you able to hear me?
Yes, sir.
Yes, sir.
Okay. Yeah. So now we are going to discuss about the concept called as Wheatstone bridge. Right? So when we talk about Wheatstone bridge, it is basically an application of Kirchhoff's law. You can ask me a question, what kind of an application it is? See, basically, let's say I give you 4 resistors, out of which I'm giving you 4 resistors, out of which 3 are unknown and 1 is known. Then you can find the, sorry, I'm extremely sorry. Correction. If I give you 4 resistors, out of which 3 are known and 1 is unknown, then you can find the unknown resistance value using the 3 known resistance values. Right? So how you are going to do is basically Wheatstone bridge is connection of 4 resistors in the shape of this kind of a quadrilateral, where the points A and C are connected to the battery of EMF E, and the ends B and D are connected to a galvanometer of resistance RG. Okay. Right. Now, if you observe, let's say the current supplied by this battery is I. Okay. Then this current I will get split into 2 parts as I1 and I2. Right. Then this I2 current is flowing towards the point B. And from here, what will happen is the current will get split as IG. and I4. So if you see what is this I4, I4 is going to be equal to I2 minus IG. Similarly, when you look at I3, right? I3 is basically I1 plus IG. So I3 is going to be equal to I1 plus IG. Okay. Now, first, I need to explain you about the galvanometer. So if you observe, galvanometer is a device like this, which has a positive and a negative terminal, and where the pointer is at the center, unlike the measuring instrument. So this is not a measuring instrument, rather this is a sensitive instrument. It acts like a sensor. Okay. So now I'm showing it for people who are online. Observe. So here you will have a positive terminal, negative terminal. You're able to see this pointer. This pointer is at the center. Right? This pointer is at the center. So this galvanometer has a tendency to rotate either in the anti-clockwise direction or clockwise direction. So whenever current is flowing through this, it starts doing a deflection. Okay. Now, if you see, there are 30 pointers on the right hand side and 30 pointers on the left hand side. Suppose I pass the current through it so that the galvanometer is showing a deflection exactly at 30 on the right or 30 on the left, then it is said to be full scale deflection. So it is said to be full scale deflection, and IG is said to be full scale deflection current, right? So if you observe, the IG value that I have taken here is called as the full scale deflection current, right? Meaning when this current passes, the galvanometer will show reading exactly at the end point of that particular galvanometer, right? Now,
Sir.
So observe. When this galvanometer shows, when current is passed through it, when the galvanometer goes and stops at 30 on this side or 30 on this side, then the amount of current that is sent through the galvanometer is called as the full scale deflection current. Am I clear with this?
Sir, I didn't understand full scale galvanometer current.
See, when current is passed through it, okay, when you pass current through this device, you connect this to the positive of the battery, you connect this to the negative of the battery. When you pass current through it, this galvanometer will start showing deflection. The pointer will turn. So when the pointer takes a turn and it starts at the extreme point or the extreme reading of this galvanometer, when it stops at the extreme reading of this galvanometer, that current which is passing through this galvanometer is called as the full scale deflection current. Break the name and see. The galvanometer is the pointer is deflected to the full scale of the galvanometer. This is called as a scale. It is going to the full scale.
So it can be positive or negative also.
There is nothing like positive or negative. There is nothing like positive or negative because it is not a measuring instrument. It can either be clockwise or anti-clockwise. That's it. It can be in either of the directions.
Yes, sir. Got it.
Yes. Okay. So this IG is called as the full scale deflection current. Now listen to this. If I take the loop ABDA, because we are saying that this Wheatstone bridge is an application of Kirchhoff's law. So what I'm going to do is I'm applying the KVL for the loop ABDA. So when I do that, when I go from A to B, then the potential drop is going to be minus I2 R2. Similarly, when I go from B to D, right? When I go from B to D, it is going to be minus Ig into the resistance of the galvanometer, that is going to be Rg. Similarly, when I go from D to A, it will be plus I1 into R1 is equal to 0, right? So when I rearrange this equation, I will get I1 R1 is equal to I2 R2 plus Ig into Rg, and I'll take this equation as 1. Okay. This equation is considered to be 1. Okay. So make a note till this point. So let me know once you're done. Okay. Listen. Now, if I take the loop BCDB, now if I take the loop BCDB, then observe this indicates when you go from B to C, right? When you go from B to C, the potential drop is going to be negative of I2 minus Ig into R4. Similarly, when you go from C to D, it will be negative of I1 plus Ig into R3. And when you go from D to B, it is going to be plus Ig into Rg, because you are going in the direction opposite to the current, right? So this will be equal to 0. When I rearrange this equation, we will get I1 plus Ig into R3 one correction, guys. Wait, don't write that. So when I take the loop BCDB, right? When I go from B to C, it is going to be negative of I2 minus Ig into R4. Similarly, when I go from C to D, it is going to be plus I1 plus IG into R3. And when I go from D to B, it is going to be plus IG into RG. Everything put together will be equal to 0. Because if you see, when we go from B to C, we are walking in the direction of current. Whereas when you go from C to D and D to B, we are walking in the direction opposite to current. Right? So when I take this into consideration, if I leave the positive terms on left hand side, then I'll get I1 plus IG into R3 plus IG into RG is equal to I2 minus IG into R4. So let me call this as equation number 2. Right? So let me call this as equation number 2. Okay. Listen. Now, we are going to do some manipulation to the first and the second equation. See, when the current through the galvanometer is 0, right? When the value of Ig becomes 0, then the Wheatstone bridge is said to be a balanced Wheatstone bridge. Right? When the value of Ig is equal to 0, the Wheatstone bridge is said to be a balanced Wheatstone bridge. When that is the scenario, you will take Ig is equal to 0 and substitute in equation number 1 and 2. Right? So if you observe, first equation is I1 R1 is equal to I2 R2 plus Ig into Rg. I1 R1 is equal to I2 R2 plus Ig into Rg. Right? Similarly, I1 plus Ig into R3, I1 plus Ig into R3 plus Ig into Rg, I1 plus Ig into R3 plus Ig into Rg is equal to I2 minus Ig into R4. I2 minus Ig into R4. Now, if I take this Ig and substitute the 0 here, this will be 0. So this term is 0. This is going to be 0, and this term will be 0. Right? When that is a scenario, I'll get I1 R1 is equal to I2 R2. Similarly, from here, I will get I1 R3 is equal to I2 R4. Right? Now divide these two equations. So when I divide these two equations, I will get I1 R1 divided by I1 R3 is equal to I2 R2 divided by I2 R4. So I1 and I1 will get cancelled. I2 and I2 will get cancelled, which implies R1 divided by R3 is equal to R2 divided by R4. So this will be the relation between resistances for a balanced Wheatstone bridge. This will be the relation between resistances for a balanced Wheatstone bridge. Okay. So you can make a note of it. Students, are you clear with this?
Yes, sir.
Yes,
Okay.
sir.
Okay. Okay. So if you see the condition for a balanced Wheatstone bridge, it says the ratio of the resistances of the neighboring resistors. If you observe, R1 and R3 are the resistors at the bottom. So R1 divided by R3 from LHS to RHS will be equal to R2 divided by R4. the LHS to RHS resistors in the top part of the circuit, right? So this is going to be the mathematical condition for a balanced Wheatstone bridge, right? So with this, we will do a problem that is based on Wheatstone bridge. Okay. So the four arms of a Wheatstone bridge have the following resistances. AB is equal to 100 ohm, BC is equal to 10 ohm, CD is equal to 5 ohm, and DA is equal to 60 ohm. Right? So there is a circuit which is in the shape of a quadrilateral where it is exactly looking similar to a Wheatstone bridge. Basically a Wheatstone bridge. Now the question is, what is the current through the galvanometer? What is the value of Ig is what we need to find in this problem. So if you observe this problem, I cannot directly write the condition for balanced Wheatstone bridge. Here, since they ask the value of Ig, I cannot write it as 0, which I took in the previous case. Why is it so? Because this is not a balanced Wheatstone bridge. So what do I mean by a balanced Wheatstone bridge? So balanced Wheatstone bridge means the ratio of the left resistor to the right resistor at the bottom, that is 60 divided by 5, should be equal to the ratio of the resistances from left to right at the top, which will be equal to 100 divided by 10. So this will be 12, this will be 10. So 12 is not equal to 10, right? Hence, this is not a balanced Wheatstone bridge. So all that we need to do is we need to apply Kirchhoff's law to solve this problem. So how to do that? Observe. So if I take the loop AB DA, if I take the loop AB DA, then I'll get, when I go from A to B, I get minus 100 I1. When I go from B to D, you will get minus 15 into Ig. When you go from D to A, you have plus 60 I2 is equal to 0. Right? So this will be considered as equation number 1, which is obtained from the loop ABDA. Now, if I take the loop BCDD, when I go from B to C, it is going to be negative of I1 minus Ig into 10. When you go from C to D, it is going to be plus 5 into I2 plus Ig. Similarly, when you go from D to B, it is going to be plus Ig into Rg. Everything put together will be 0, and let this be equation number 2. Okay. Similarly, if I take the loop AB, C, and A, if I take the loop AB and ABC and A through the battery, so through the battery, when we go from A to B, it is going to be minus 100 I1. When you go from B to C, it is going to be minus 10 into I1 minus Ig. Right? When you go from C to A through the battery, it will be plus 10 is equal to 0, and let this be considered as equation number 3. Clear? Taking from here, it is going to be like this. Okay, clear with this? So listen, what will happen is 0 will get cancelled. Minus 10I1 minus I1 is minus 11I1. Minus of minus is plus Ig is equal to 0. So which implies, okay, sorry, wait. Minus Ig plus 1 is equal to 0, which implies Ig is equal to 11I1 minus 1. Ig is equal to 11I1 minus 1. So let this be equation number 4. So what you need to do is take 4 and substitute in 1 and 2. Then you will get two linear equations. So then you will get two linear equations from which find out the value of I1. So once you get the value of I1, substitute it here and find the value of Ig. Okay. So I'll give you time, do this and show it to me. So what you need to do is take the fourth expression and substitute it in second and the first one and get two linear equations in I1 and I2. Right? So from I1 and I2, solve for I1. Once you get that I1 substituted back in the fourth equation, you will get the value of Ig. Okay, start doing it. Yeah. Students keep doing it. I'll be back. I want to know what is the answer. Okay. I'll be asking you what is the equation 1 and 2 after Ig is substituted. Anybody with the answer? Is anybody with the solution? Can I proceed? Guys, I'm asking you, after you substitute this Ig value in expression 1 and 2, what is the final expression you're getting? So 15 Ig plus 100 I1 is equal to 60 I2, right? 15 into what is the value of Ig?
11 I1 minus.
Yes. So it is 11 I1 minus 1 plus 100 I1 is equal to 60 I2. So it is going to be 265 I1 minus 15 plus 100 I1 is equal to 60 I2. So it is going to be 365 I1 correct?
Won't it be 165?
It is 165, yeah. So 165, this will become 265, right? So 15 will cancel this 4 times, this will be 1 time, and this will be 11 times. So basically, 11 I1 minus 1 is equal to 4 I2. Am I right? Correct. 11 I1 minus 1 is 4 times I2. Similarly, what is the second equation that we got? Minus I1 plus Ig. So minus 10 I1 plus 10 Ig plus 5 I2 plus 5 Ig plus Ig into Rg is equal to 0. So minus 10 I1 plus 10 into what is the value of Ig? 11 I1 minus 1 plus 5 I2 plus 5 into 11 I1 minus 1 plus Ig into Rg is equal to 0. So minus 10 I1 plus 110 I1. So basically it is minus 10 I1 plus 110 I1 minus 10 plus 5 I2 plus 55 I1 minus 5 plus in this place also I'll substitute 11 I1 minus 1 into the value of Rg is going to be 15 basically, right? So here it will be 15 will be equal to 0. Now observe 110 plus 55 I1 is 165 I1 plus 265 I1, right? Minus 10 I1. There is no I2. Plus 5 I2 will be equal to 15. So it's basically not 165, it is 155 because 110 minus 10 is going to be 100, 100 plus 55 is 155, 155 plus 15 into 11 is 265. So this will be 320 times I1. Is it 320 or 420? It is 420 times I1.
Sir, if you have taken out the yes.
Yeah, I removed it. 420 I1 plus 5 I2 is equal to 15. Now I'll cancel this 5. This will go 3 times. This will go 84 times. So basically, I'm getting 84 I1 minus 3 is equal to minus I2. Okay. I'll multiply this with 4 and then add both the equations. So 4 into 84 is how much? 4 into 84 is 16, 1, 336. So 336 I1 minus 12 is equal to minus 4I2. When you add both the equations, 4I2 and 4I2 will get cancelled. Minus 12 minus 1 is minus 13 is equal to 0. So 336 plus 1 is 347 I1. So I1 will be equal to 13 divided by 347. Then what is the value of I2? Sorry, what is the value of IG? It is 11 into 13 divided by 347 minus 1. So 11 into 13 is 'So check the calculations.
Sir,
Ah,
how come 265 I1 comes, sir? 11 into 15 is 165 only now.
165
இல்ல
plus
sir,
some.
second இதுல.
எங்கடா?
You written 155 I1 plus 265 I1, no?
ஆமா, இரு. ஏன் 265 னா 15 into 11. Oh, this is 165 only.
Yes, sir.
அப்ப this should be 320.
Mm.
Okay. So this should be 320 I1, correct? So this should be 64 then. So when this is 64, then this will become 256. This is 64. This will become 256. So 256 plus 11 is 267. Right? 267 I1 minus 12 is equal to, sorry, minus 13 is equal to 0. So I1 is equal to how much? 13 divided by 267. So what will be the value of IG? 11 into 13 divided by 267 minus 1. So how much is the answer coming to? 11 into 13 is 143 minus 267 is 124 divided by 267. So answer is coming out to be 0.464 ampere, but you will get a minus sign. Here, the meaning of minus sign is that the current direction that we assumed is wrong. Actually, the current in the galvanometer is flowing from D to B, not from B to D. Okay. So the answer is 0.464 ampere. So what is the answer given in the textbook?
4.87.
4.87 what?
The 4.87 milliampere.
Okay.
Sir,
Tell me.
sir, 321 I1 plus 5 I2 should be equal to 13, no, sir. Minus 10, minus 5, and minus 15.
It's 13, huh?
30, sir.
So minus 10,
Minus 5, minus
minus
15.
15. Oh, minus, oh, so this should be 30 then.
30, yes, sir.
Then this should be 6, sir.
Yes, sir.
If that is 6, correct. If this is 6, then this should be 24. So 24 means this will be minus 25. So if this is 25, this will be 25 by 267. This will be 25. So 11 into 25 is 375. Okay, let me check. So 375 minus 267 divided by 267. 0.404 is what I'm getting. .404 ampere is what is coming. So 64 I1 minus 6 is equal to minus I2. I multiplied with 4 on both the sides. So there is no mistake with this side, no?
No, sir.
Okay, 0.404 should be the answer. Answer is given as 4.87 milliampere.
Yes, sir. 4.87.
Okay. So this problem, I would suggest you guys to try it again. But you understood the concept, no? See, I'm generally, like, I don't concentrate much on calculations while solving. So I want you guys to concentrate and do it. I'm concentrating only on teaching you how to solve this problem. Right? Did you guys understand the approach? So there are two things that you need to know about this problem. One is, here the value of Ig is not equal to 0. Suppose this question comes in MCQ, okay, and here instead of 100, had they given it as 120, then what would be the value of Ig? Instead of giving it as 100, had they given it as 120, what would have been the value of Ig in this scenario?
0, sir.
Yes. Why is it so? Because it's a balanced Wheatstone bridge. 120 by 10 is the same as 60 by 5. So you need to be careful. Okay. Had it been, okay. See, this is about the concept of Wheatstone bridge and a problem that is based on it. Okay. So with this, the theory of this chapter comes to an end. So we are done with theory. All that I'm going to concentrate next is, I'll be concentrating on PYQs. That is the previous year questions from this particular chapter on how they will ask you. I'll be solving the problems alone. Is the point clear? Clear?
Yes, sir.
Okay. So that's it from my side for today. In next class, we'll start with the PYQs.
Thank you, sir.
Thank you, sir.
Thank you.
Thank you.
Thank you, sir.